Continuous variables. We'll discuss a little bit about what is data, what types of data are there, the variable checklist items you should consider when looking at your data, the shape of distributions, and measures of central tendency, or where the middle of your continuous data is. So what is data? Very simply, data are individual units of information. Collectively, data refers to all information to be used for analysis. You'll hear the terms data, data set, database. Database generally refers to a large number of particular data sets. Data is often used interchangeably with the concept of data sets, though data or datum can be an individual data point as well. So what types of data do we have? There are two basic types of data in biostatistics, continuous and categorical. Let's first very briefly look at categorical data. Categorical data comes in named categories. They are mutually exclusive groups. That means there's no overlapping between the groups. They can be ordered, so they can go from high to low. They are not always consistent scales, meaning that the difference between group A and group B doesn't have to be the same as the difference between group B and group C. And we'll talk much more in Module 3 about categorical data, but let's look at a few examples. Categorical variables can be what's called nominal, name only, or ordinal. So there's an order to them. Common categorical variables that you have seen are gender, which is self-identified, so male, female, transgender, other. Sex, which is genetic. Ethnicity, Hispanic or Latino versus non-Hispanic, non-Latino, and that's ethnicity is recognized in the U.S. Census. Age group, where you check a box, so those between 20 and 29 years of age, you would check that box. You're not giving your actual age value. You're simply checking the group in which you are a member of. BMI or body mass index group. So the categories underweight, normal, overweight, or obese, not the actual metric of BMI and not the weight value. It's important to understand the distinction between categorical variables, so things that are collected in categories, and our next variable type that we will look at, which are continuous variables. Continuous variables are numerical data. They are quantitative. That means you can quantify or count the specific numbers. They can be measured, and they have a consistent scale, such that the difference between a 34-year-old and a 35-year-old is 1 year. And that's the same difference of 1 year as there would be between a 22-year-old and a 23-year-old. So a consistent scale of measurement. Let's look at some common examples. Continuous variables, again, are a number from a scale. They can have one unit or multiple types of units. Considering age, age could be collected in years. So 21, 22, 87, 104, or commonly in premature babies or in young infants, age may be collected in weeks, or you'll often hear people refer to the months up until 2 years, and then 2 years, 3 years, 4 years. So age can be collected in multiple units. Weight could be in pounds or kilograms, so that's a different type of scale. Systolic blood pressure is captured in millimeters of mercury. However, there are also some different metrics for systolic blood pressure. If it's arterial pressure, if it's captured using a cuff on the arm. So the unit and how, or the mechanism of measurement, can be important. Continuous variables can be categorized after data is collected. So blood pressure could be categorized as high blood pressure, 130 plus, or normal blood pressure, less than 130. So you would only have two categories there, high or normal. You could do the same with BMI, taking weight and height of the person and calculating the actual body mass index value. That becomes a continuous variable, which you can then categorize later. It's important to note that if data is collected in categories, that you cannot make it back into a continuous variable. So if you collect data as age group, where people check only a box 20 to 29, you can only report on that group variable. You would not be able to determine the numerical value of each respondent. If you can, collect continuous data in the most natural form that you can get it, and then you can transfer it to a categorical variable later if needed. So with our two types of data, categorical, which we'll look at more in Module 3, and continuous, what are some of the questions you need to ask yourself about your data? Anytime that you get a data set, you need to look at each variable. You need to look at what are the variables called, what are their names, how are the variables measured? So is it a categorical variable? Is it captured in groups, or it is a continuous or numerical value? If it's numeric, what is the unit of measurement? For example, is it years? Is it pounds? Is it mmHg? Is it BMI? What are the units of measure for those variables? So for each variable in every data set you get, you need to look at what the variable is called, and not just what it's called, what does that mean? So we won't be using variable names when we write. So if the variable name was BMI underscore 1, that's not how you would write about it. You would write about it as the body mass index, or the BMI for short. So make sure you understand what each variable name is and what the actual variable is, or what the question was. How the variable was measured, so how was it captured? And then if it is a continuous measure, what is that unit of measure? The first thing that we do with a continuous variable, with any variable actually, but with a continuous variable particularly, is try to understand the shape of the distribution. Before you can summarize the data, you need to determine what does it look like when it is plotted. And we will do this in JUMP. With continuous data, there's two basic shapes. Symmetric, as seen here on the left, where there's a single or unimode in the middle, and then roughly equal amounts of data as you go away from the center. On the right side is data that is skewed. And what that means is that while there may be a unimode, as you move to one side away from that peak, there's much more data than there is on the other. So we're either looking at symmetric or skewed. A good thing to keep in mind, if you've ever heard of something called the bell curve, i.e. shaped like a bell, that is a symmetric data variable. Skewed data can come from many sources, but we report it in a different manner. It's not appropriate to report the mean value that we're used to hearing about, which we will only report for symmetric. And that takes us to the concept of central tendency. So from the name central, you should understand that we're talking about the center or middle of the data, and where does it tend to be? When we are describing the center for symmetric data, we can use the mean value, which is the average of all data values. If it's skewed, we should use something called the median. And that is very literally the middle point of the distribution, where 50% of the data is lower than that median value and 50% of the data is higher than that median value. So when we talk about symmetric distributions, it's appropriate to report the mean. When we see that a distribution is skewed, it's appropriate to report the median. When we look at continuous variables, we need to remember to understand how is the data collected, what are the units of collection, what is the shape of the distribution, and from there we'll understand which reporting value or summary statistic, the mean or the median, we should use. Next, watch the JUMP instructional video for the practice exercise for Module 2. Open the SBP_weight dataset in JUMP and open the Practice 2 worksheet. What you will do is examine the distributions, determine the shape of each of the variable distributions, and determine the measures of central tendency that would be appropriate for each of the values.